So let's get to some graphing. So here we're, in this case, the math becomes very visual. And in order to graph any equation, I've got 3 of them here, what I need to do is find what are commonly known as solution points. Right? I don't think I need that S there. Solution point. What a solution point is, it's a data point, an x comma y value, that when I plug it into the equation, makes the equation true. Right? So one way to do this is to do point plotting. All right, so you probably saw the old skill where, maybe I let x equal 0, or you had a data table, right, and you simply just let x equal 0. Plugging that in, right, we would get something like this. 4 times 0 is 0, and so we're left with negative 3y equals 12. Play our golden rule and divide both sides by negative 3, and we get that y is equal to negative 4. So I just found a solution point. I can come over here now, and when x is 0, y is 4, I can plot that point and be done with it. All right, so that is point plotting. However, there turns out that there's an easier way to do this in making use of slope. All right, and so another review topic, let me scoot down here, is there's basically 3 line forms. There's the general form, right? That's kind of what you're looking at right now, right? ax plus by equals c. So that's the form that we have here. There's the more famous slope-intercept form. You guys famously know that as y equals mx plus b, right? That would be this guy right here, right? And then there's the other infamous form that I think is just as important, the point slope form. Y minus y1, sorry, the paper is kind of bouncing on me, right? Y minus y1 equals, that's an m there, x times x minus 1. And you can kind of see that down here. So there's basically 3 line forms. We could do all this point plotting that I did here, but that gets a little lengthy, especially when things get a little hard. What I'm going to do is take advantage of what these forms are, where I know what the slope is, so I know how to move from point to point. And then this one gives me a y-intercept, and this one actually gives me a point to plot. So what I'm going to do is take this equation here and convert it to a more useful y equals mx plus b form. So using the golden rule, kind of the equation things that we did earlier, right? I'm going to subtract 4x from both sides. We'll get negative 3y equals negative 4x plus 12. Divide both sides by negative 3, and we end up with y equals, remember there's 2 fractions here. One of them is 4/3 x, and then 12 divided by negative 3 is a minus 4. So what this is now telling me is that my slope is 4/3, and my y-intercept is 0, negative 4. Well, that already kind of supports what we found when we were doing some point plotting. Right? So I know I'm going to be starting at 0, negative 4, and then this slope, remember this is the change in y over the change in x. So to go to another solution point, I need to go from the one that I have, march over 3 units to the right, and then march up 1, 2, 3, 4 to the left. Or excuse me, up, right? So my change in x was 3, and my change in y was 4. And so that basically gives us the ordered pair 3, 0. A really quick check, right? If I put 3 in here, 4 times 3 is 12, 3 times 0 is 0, 12 equals 12. So you can see that it's still another solution point. The beauty about this is I can just keep going, right? How do I find another solution point? We'll move over 3 and then up 4, and we just found that 6, 4 is another solution point. We could also go down 4, 1, 2, 3, 4, and then back 3, and there's another solution point. It looks like it's what? Negative 3, negative 8. So where are all the rest of them? They essentially fall along this line right there. So that would be a visualization of all the solution points to the equation 4x minus 3y equals 12. That one was a little hard because we started in general form, right? And I was kind of coaching you along. There's basically two ways to do it. The point plotting way, which I kind of stopped doing, and then let's convert it to a more useful form and make use of my slope and my intercept. What's nice, I just realized that this is A and this is A. I guess this should be B and that should be C. What's nice about the next example is it's already in a very useful form, right? It's already in the slope-intercept form that we want. So in this case, I can see that the slope is -3/2. The y-intercept is 0, 4. So I can go over to my grid and plot the point 0, 4. And then the slope is basically telling me to move over 2 in the x direction, but this time drop 3 in the y direction. And I just found another data point. Keep moving, right, over 2, down 3, and it looks like we have 4, -2 is another one. Or we can reverse this. We can actually go up 3 and back 2, and it looks like -2, 7 is another solution point. So connecting all my dots, right, there would be the graph of y equals 3/2 x plus 4. All right, now the next problem, a little more complicated, but remember, there's another form that we have here. This form, as the name suggests, is telling me what the slope is. That's that m that's standing in front of the x minus part, and then we're subtracting x1 and we're subtracting y1, which is my ordered pair. So let me kind of rewrite the formula here. This is y minus y1 equals m x minus x1. So this point, this equation form is just as useful as our slope-intercept form because it's telling me what my slope is, right? That's telling me how to move to a point, and then it's also giving me a point. X minus 1. So what are we subtracting from x? We're subtracting 1. So that means my x1 is 1. And then we're subtracting 3 from the y, which tells me my y1 is 3. So I now have a point and I have a slope. It's basically the same idea that we did there. I'll go to my grid. I'll plot the point 1, 3, which is right there. And then the slope is telling me to move over 4, 1, 2, 3, 4, and up 1. Right? So it looks like my other data point is 5, 4. Go over 1, 2, 3, 4, and up 1. And it looks like we have 9, 5 is another one. We can also reverse this, go down 1 and back 4, and it looks like we have -3, 2 as a solution point. So connect my solution points, and we have basically graphed the line. Alright, so that is how you graph lines. Again, it's all about finding solution points, ordered pairs that solve the equation. You can do the old-fashioned, which I kind of recommend. I mean, it's a good thing to know, but it's a little easier to use two very famous forms. The very well-known slope-intercept form, slope and an intercept, a y-intercept, or kind of the ugly duckling, if you will, the point-slope form, where you have the slope and then whatever is being subtracted from the x and the y gives you your x1 and y1 in a data point. As soon as you have a point and a slope, you plot your point and then move the way the slope tells you to do, and that helps you generate some new points, or like I said, solution points for our equation. Alright, so again, to practice these skills, we're talking about R3. We're putting our slope and our point plotting to work. Alright, and that about does it for this video. We're almost about 9 minutes in. I still have another couple problems to do, but I'll cut a video for those coming soon. Alright, so keep your review going. Hoping you're having a lot of aha moments, and I'll talk to you in a video coming soon.